People carry out duties, jobs, and projects for their employer in a workplace, often known as their place of employment. Workplaces can be found inside or outside of a structure and vary by industry. On certain days, certain employees might operate in several locations, and mobile workplaces are also an option. Technology advancement has led to the emergence of a new type of workplace, a virtual one that allows people to work from anywhere. Workplaces help companies reach clients with their products or services. Teams within organizations collaborate to create innovative concepts, goods, and services to promote to their clients. Businesses use factories to manufacture their products and distribution centers to organize the shipment of those products to retailers or end users. Stores exist to facilitate product purchases by giving customers a physical location to view the goods. The workplaces we are familiar with include, for instance, offices, factories, schools, laboratories, and many more. 30 years ago, on April 26, 1986, the Chernobyl nuclear power plant exploded, sending tons of radioactive elements into the atmosphere and hurting millions of people in the Ukraine and neighboring countries due to the fallout. In the end, 600,000 armies and civilian troops from across the Soviet Union were appointed as clean-up workers, or locally known as liquidators, and 350,000 residents were permanently transferred away from the complex. By the 20th anniversary of that year, papillary thyroid cancer, usually uncommon illness, had been identified in 6,000 children under the age of 18. On the 25th anniversary, it was shown that the liquidators were more likely to get cataracts, thyroid cancer, and leukemia. But over time, the Chernobyl disaster has had a particularly large impact on mental health, leading to considerable melancholy, anxiety disorders, PTSD, and stress-related symptoms. The most vulnerable populations have been individuals from the Chernobyl region who were pregnant or already had young children in 1986, as well as liquidators, particularly those who worked at the site between April and October of that year. The detrimental effects on mental health were worsened by the exaggerated impression of the health hazards connected with supposed radiation exposure, which was supported by the local medical community and government officials. The media used terms sufferers or Chernobyl victims were formerly used to refer to liquidators, evacuees, and inhabitants of contaminated areas. Chernobyl victims were eligible for financial assistance, as well as medical, educational, and other benefits. This could have an effect on people's mental health, along with continued oversight by regional and international organizations.
Hi, my name is Ahmad Ashraf Muhammad Ali, and I will present to you the chronology of Chernobyl disaster. On 26 September of 1977, the Chernobyl nuclear power station located about 60 miles north of Kiev, Ukraine, began supplying power to the grid. On February 1986, a Soviet official is quoted saying that the odds of nuclear meltdown are 1 in 10,000 years. On April 25, 1986, at 1 a.m., Chernobyl operator began reducing power at reactor number 4 in preparation for safety tests, which they have timed to coincide with a routine shutdown for maintenance. The test is supposed to determine whenever, in the event of a power failure, the plastic spinning turbine can produce enough electric to keep coolant pump running during the brief gap before the emergency generator kick in. At 2 p.m., reactor number 4 emergency core cooling system is disabled to keep it from interfering with the test. Though this doesn't cause the accident, it worsened the impact at around the same time. The test and the shutdown are temporarily delayed to accommodate the region's power need. At 11 and 10 p.m., operator received permission to continue with the test and shutdown. By now, the less experienced night shift is on the job, which purportedly never received proper instruction on how to perform the test. On April 26, at 12:28 a.m., power plummeted to far below the level at which the reactor is considered stable. Operator responded by removing most of the control rod in violation of the plant safety guide, yet they still have trouble raising the power, in part due to xenon buildup in the core. At 1 a.m., the power stabilized, albeit at a lower than preferred level. The plant supervisor ordered the test to proceed. The automatic emergency shutdown system and other safety features are subsequently turned off. At 1:23:04 a.m., the test officially began, and an unexpected power surge occurred. At 1:23:40 a.m., an operator pressed the emergency shutdown button, but the control rod jammed at the enter of the core. At 1:23:58 a.m., the first explosion to be quickly followed by at least one more below the 1,000-ton roof right of the reactor and shoot a fireball high into the night sky. A blackout roiled the plant as the air filled with dust and graphite chunks. The radiation began spewing out. Walls and equipment collapsed, and a dozen of fires started up, including one on top of the neighborhood reactor. Despite all evidence to the contrary, the nuclear engineer in charge of the test insists that reactor number 4 is still intact. He later dies of radiation poisoning. At 1:28 a.m., the first firefighter arrived at the scene. They have no knowledge of the radiation and wear no protective clothing. At 2:15 a.m., local survey officials convened an emergency meeting at which they decided to block cars from existing or entering Pripyat. Police officers existing with the roadblock likewise will have no knowledge of the radiation and wear no protective clothes. At 5 a.m., reactor number 3 officially shut down, followed by NOS 1 and 2 next morning. At 6:03 a.m., all the fire have been extinguished except the blaze in the reactor core, which will burn for days. On 10 a.m. of 27 April, helicopter began dump clay, boron, lead, sand and dolomite into the burning core in attempt to slow down the radiation emission. April 28, Swedish Air Monitor detect a large amount of radiation in the atmosphere, which is traced back to the USSR. On May 4, liquid nitrogen is pumped underneath the dead reactor in order to cool it. Other aspect of the cleanup, which is involved up to 800 workers, including bulldozing contaminating village, shooting contaminated pet and livestock, and burning huge amount of contaminating topsoil. On May 6, radioactive emission dropped sharply, possibly because the fire in the core has burned itself out. Meanwhile, Soviet officially closed school in Kiev and advised residents to stay inside and do not eat leafy vegetables. On May 8, workers finished draining about 20,000 tons of radioactive water from the basement under the core. On December 15 of 2000, Unit 3, the last working reactor at Chernobyl, is shut down. Unit 1 and 2 had been shut down in 1996 and 1991 respectively.
My name is Zaru Afizul, and I will continue with this presentation. As you guys know, accident can happen to everyone. So actually, what is accident? Accident can be defined as any unplanned event that cause genuine injury or illness. Meanwhile, near-miss incidents can be defined as incident which no harm or illness sustained. But in this case, it's about accident in workplace. So, what is accident in workplace? A workplace accident, commonly known as occupational accident, is an unforeseen event in the workplace that results injury or casualty to an employee. Common workplace accident that may happen is animal or human attacks, cases of acute poisoning, slips and falls on stairs or pavement, or accidents that happens while on board of any mode of transportation. So that's all from me. I will pass this presentation to the next presenter.
Overview. Accident. The Chernobyl accident in 1986 was the result of flawed reactor design that was operated with inadequately trained personnel. The disaster occurred on April 25 to 26, 1986, when the technicians at reactor unit 4 attempted a poorly designed experiment, resulting steam explosion and fire release at least 5% of the reactor core into the environment, with the deposition of radioactive materials in many parts of Europe, causing casualties at an estimated total of 3,940 deaths from the radiation-induced cancer and leukemia, and also including 31 people that died as an immediate result of Chernobyl. Casualty estimated total value is around 40,000 deaths for the radiation and 31 people that died as an immediate contact with accident. Incident place is a reactor unit for Chernobyl nuclear power plant, Ukraine. Time and date of the event is 1:25 am, April 26, 1986. After the accident, the Chernobyl operator began lowering the power at reactor 4. The emergency cooling system reactor number 4 is turned off and the test temporarily postponed. During the incident, the test officially began at 1:22 am. Unforeseen spike occurred. Failed to use the emergency button has led to explosion occurred. The local Soviet official convened an emergency conference. After the incident, helicopter came and posed sand, clay, boron, lead, and dolomite to reduce radioactive emission. Soviet officials began evacuating people at May 14, because the nitrogen were injected beneath the reactor.
I will continue this presentation with root causes of Chernobyl disaster. For root causes of Chernobyl disaster, there are many factors that may contribute to this disaster, including, first one, serious flaws in design, including core stability characteristics, the shutdown system effectiveness, the core containment inability to handle numerous fuel channel ruptures, and secondly is a lackluster approach to independent safety review and inadequate safety analysis. And next, a lack of adequate and effective communication between RBMK plants as well as between plants and the designer on crucial safety information. And then, the operator's lack of awareness and respect for the safety implications of operational and testing process. And last but not least, a feeble regulatory structure that couldn't fend off production constraints. So that's all from me. I will pass this presentation to the next presenter.
Assalamualaikum, I am Isma Adam Belakpi and I will present about control measures. The practical control measures need to support corrective and long-term countermeasures. For example, we need to estimate the amount of human exposed to disaster in future. After that, the government should inform the general public in affected areas about changing radiological conditions in order to relieve public concern. Furthermore, for the scientific aspect, some organization needed to improving predictive model for use in Chernobyl affected area to determine the parameters of the long-term transfer of radionuclides in varied natural circumstances. Next, we need to determine the mechanism controlling radionuclide behavior in less steady ecosystem in order to comprehend the mechanism controlling radionuclide persistence. As the result of Chernobyl disaster, they adopted regulations on nuclear safety, accidents, and many more. At the same time, the ILO and other international agencies adopted international standards and safety guidelines, including the International Basic Safety Standards for protection against ionizing radiation and for the safety of radiation sources, and in cooperation with the International Atomic Energy Agency and other international organizations. Furthermore, the International Labour Organization (ILO) adopted occupational safety and health guidelines on OSH management system in 2001.
The conclusion is Chernobyl disaster is the incident of the result of a flawed reactor design that was operated with inadequately trained personnel. According to OSHA in 1994, Part 5, Section 20, General Duties of Designer, Manufacturer and Supply a safeguard plan for use at work, which is the plan is designed and constructed as to be safe and without risk to health when properly used. According to OSHA, Part 6, Section 34, General Duties of Employee at Work to give necessary information, instruction, training, and supervision to ensure the safety and health of his employee at work.